Hello. Let's talk about an application of derivatives. Coming from economics, we're going to talk about marginal cost and rates of change, how those two things interplay to each other. So I'm thinking of this as being in the broad category of estimating using f prime. And I think it's a pretty sweet application. So the first thing we have to talk about is marginal cost, and then we'll do an application of it. So the marginal cost in the world of economics is the cost to produce one additional unit. Generally speaking, we're thinking about having some function f, and you feed in values. So this axis right here is the number to produce, and this axis is the cost to produce that many. And if we're lucky enough to have f, then we don't necessarily need to estimate using f prime. But check this out. So this property is pretty sweet. So here's our f. I'm just going to go ahead and sketch in the tangent line. The tangent line looks like that. Okay. And they're really not that different in terms of this height right here, right? That difference is pretty small. So what's that value? So this is the actual value of f at p plus 1. This other value is estimated. That other value is estimated. And we're going to get a hold of that value by working on this line, the slope of which is f prime at p, because p was the point of tangency. And so check it out. So if you're here, you go rise over run. So it goes up this many units. For every many units you go over, the distance there is 1, because we're thinking about it taking one more. We're going to produce one more unit. Well, how far do we go up in that distance is exactly given by the derivative. So that height is f prime at p, right? So the marginal cost is well estimated simply by taking f prime. F prime. And we're thinking about f prime at p being a good estimate for f at p plus 1 minus f at p, which is the difference in those two costs. So it's the cost to produce one more unit if you're already using p. And we really need to pay attention to p because it costs different rates to manufacture different amounts of different things. So the point is that you can use the derivative to estimate differences in function values. And let's go ahead and do that in an example. I've got an example that I'm going to work with here. And I'll transcribe that up to the board as I work on this problem for you. Okay. So, kind of not into standing behind this, so I'll erase it. So, generally speaking, we're going to have some cost of production, and we're having you explore this relationship. We're not doing economics in this class, so this isn't a study of marginal cost per se. What we're doing is we're using marginal cost, the concept of how much does it cost me to produce one more, that's this. We're using that to illustrate estimation by derivative, which is really powerful. Okay, so I think I can actually erase these things also, so that I can put the problem on there. If you fast forwarded through this, that's probably reasonable. The irony being that if you fast forwarded through this, you probably didn't hear me say that it was fine for you to have fast forwarded through it. Lol. Alrighty then. Okay, so here comes the setup for the problem. So we're going to say that demand for oil is D of P is equal to 900 over P, where P is the price per barrel. So let's check and make sure that this makes sense. So as the price per barrel goes down, we're going to make a smaller number right here, and then we're going to be dividing by it. So we're going to get a bigger number. So as price goes down, demand goes up. And if price gets bigger, then we're dividing by a bigger number, and demand is going to go down. Well, that seems pretty reasonable. People like things when they're cheaper. So that's pretty reasonable. And we're going to find the demand when P is 40, and then we're going to estimate the increase in demand if the price goes from 40 to 39 or 40 to 41. So those are our two scenarios that we're going to think about. And we're going to estimate the increase in demand. If the price, this says price, I swear it does. If the price goes from 40 to 39 or 40 to 41. So these numbers are off by 1 from each other. Okay, marginal cost, sweet. We're going to have the demand, and we're going to see how the demand changes. And we're going to do that using the derivative. So here we get to practice our derivative skills. I've got myself a power function right here that's the same as 900 times p to the minus 1. So we'll have that d prime at p is equal to minus 900 over p squared. Go ahead and check that using the rules for derivatives if you want. Its value at 40 here is going to estimate these things right here. So d prime at 40 is equal to, let's see here, minus 900 over 40 squared is minus 900. 40 squared is 1600 is minus, we're going to cross out those zeros, and we'll have minus 9 over 6. Okay, so the derivative is always in terms of going that way. So we're on some curve that looks like that. We've got the derivative pointing down like that. I know it looks like this because it's a 1 over p, like 1 over x. It's like that. We always take the tangent and think about the derivative moving in that direction right there. So if we increase the price from 40 to 41, then the demand is going to go down by 9/6. Or I guess we could reduce that and call that minus 3/2. That's off screen. Good job, Danielle. Yeah. So the demand is going to increase by minus 3/2. If the price goes up by 1 and if the price goes down by 1, then the demand is going to increase by 3/2, right? Because we're going to be going this direction and it's going to go up. Let's compare our estimated values with the actual values. So the demand at 41 is equal to 900 over 41, and 900 over 41 is, should have gotten my calculator out already. There's no way I'm going to be able to do that division in my head. 900 divided by 41 is 21.95. This number is wrong. This is 9 over 16. Okay, that makes more sense. Okay. You'll see why it makes more sense in just a second. I was looking ahead. So we'll see that that number was wrong. That 9/6 was wrong. That the 3/2 was wrong. And so there's a check coming up here. Okay. So this is the demand. If the price per barrel is $41, it's 21.95. D at 40 is 900 over 40, which is 22.5. And D at 39 is 23.07. Okay, so check it out. So I've got this one right here. This is like the base one that we're considering. We're focusing our attention on this. This is the root for our estimations. So check this out. So if I take this value right here, this 22.5, and I add that value 9 over 16, minus 9 over 16, 22.5 plus minus 9 over 16, I should get about that value. So 22.5 plus negative 9 over 16 is 21.93, which is almost 21.95. It was about the same because the estimate is pretty tight as far as that goes. Okay, so, and if I take 22.5 minus 9 over 16, this should be about D at 39. So let's go ahead and run that number and see how close we were. 22.5 minus negative 9 over 16. Ooh, 23.06. Oh, yeah. Oh, that's wicked cool. 23.06. 23.07 was the actual function value. That's pretty awesome. Yeah, that was totally a successful estimate. And I'm a fan. So, overall story, let me give you the summary again of the overall story. Marginal cost is the cost to produce one more, or whatever cost happens to be. The thing for one more. And you can estimate function values that are one off simply by taking the derivative and adding the value of that derivative to the original base function value to estimate new function values one off. So I think I'm going to stop there and say thanks for watching, and I hope you have a nice one. Bye.